Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the JWT attacks module titled JWT Authentication Bypass via JKU Header Injection. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs, and then do a search on JWT labs and go to lab number 5 titled JWT Authentication Bypass via JKU Header Injection. Alright, let's get started. This lab uses a JWT-based mechanism for handling sessions. The server supports the JKU parameter in the JWT header. However, it fails to check whether the provided URL belongs to a trusted domain before fetching the key. To solve the lab, forge a JWT that gives you access to the admin panel at /admin and delete the user Carlos. You can log into your own account using the following credentials, and we're giving credentials of a regular user account. Okay, so the goal over here is to forge a JSON web token by adding the JKU parameter, accessing the admin panel, and then deleting the Carlos user. Let's access the lab. Now notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. We will be using the JWT editor extension, so if you haven't downloaded it from the previous labs, make sure that you download it right now. All right. First thing we're going to do is click on my account and log in with the regular credentials that we were given. So the password was Peter. Hit login, and notice right away our login request is highlighted in green, which means that it contains a JSON web token. So if we make this a little bit bigger and we put the request and response side by side, you could see that when we log in on our post request, it takes in a CSRF parameter, a username, and a password. Now the application in the backend checks the username and password, and if they're correct, it will set a session cookie that contains the JSON web token. And this JSON web token will be sent with every request as a cookie. So if we click on this request over here and send it to repeater, you could see over here, we've got our JSON web token being sent as a cookie. Now, if we go to JSON web token, and let's close this off so that we have more space, you could see that we've got the header, the payload, and the signature. And in the payload of the JWT, the subject is the regular user account. So now we need to find some kind of attack where we can change this to the administrator user account, and the application is going to accept our new JSON web token. In the previous labs, we've learned about 4 attack vectors. We're going to assume that we've checked all these 4 attack vectors and they didn't work. And so the 5th attack vector that we're going to try is check if the application accepts an arbitrary JKU header. So in the previous lab, we were able to exploit the application by injecting a JWT parameter. So this is written incorrectly. It should be parameter, and same goes for here. But if you remember, in the previous lab, we were able to inject a JWT parameter where we entered our own key. And so we were able to sign the modified JSON web token with our own key and send it to the application. Now in this lab, we're going to attempt to inject the JKU parameter. JKU stands for JSON Web Key Set URL, and what it does is it essentially includes a URL from which the server can fetch a key or a set of keys to verify the signature of the token. Now, if the application allows you to enter any JKU parameter, so an arbitrary JKU parameter, and it actually accepts it without any verification, then you could add a URL in that parameter which includes your own key set and use that key set to sign the token. When you do submit the request, the application will fetch the URL and use your public key to verify the token, and so the verification will pass. And that's exactly what we're going to do. Now, there's a few steps to this exploit, and so we're going to write them down over here just so that we don't miss anything. So the first thing that we're going to do is generate our RSA key, and then we're going to add the public key in the exploit server. Once it's added in the exploit server, we're going to modify the JWT to include the JKU parameter and the subject administrator. And then we're going to sign the JWT using the private key that is corresponding to the public key in our exploit server. And so when the application receives the JSON Web Token, it'll look at the JKU parameter, it'll see that there's a URL there, it'll fetch the URL, from there it'll extract the public key and it'll use it to verify a token that was signed with the corresponding private key, and so the verification is going to pass and we should be able to access the admin panel. Okay, so let's do that. First, I'm going to send the request to make sure that my application did not time out, and it didn't. Now, the first step, like we said, is to generate our RSA key. So we go to the JWT editor extension, click on New RSA Key, and click on Generate, and then click OK. The next step is to go to our exploit server and add our key. So it has to be in a specific format for it to accept it. And that looks like this. So we've got curly brackets, and then inside the curly brackets, let's just add a few spaces. The space doesn't really matter. Say keys, colon, and then square brackets. And then we have to go back to our JWT editor extension, right click, and select copy public key as JWK, and then enter it in between the curly brackets. All right, that looks good. Now we're going to click on store. So right now we've got our own generated public key that is saved in our exploit server. So if we go back over here to the list of steps, we've performed this, and we performed this item as well. Now the next step is to modify the JWT to include the JKU parameter and the subject administrator. So if we go to repeater, I'm going to hit send again so that it does not time out, and go to the JSON Web Token tab. From there, you need to change the KID to the KID of the key that you're using. So it would be this one. Let's copy that. And it'll differ based on the key. So we'll paste it in here. We also need to change the subject to administrator. And we need to add the JKU parameter. So we're going to add a comma and then add JKU. And then add the exploit server's URL right over here. So let's copy it. In a real engagement, you would use your own exploit server, but for the lab environment, you have to use the exploit server of the lab. So I don't know if that actually added a quote, and it did. All right, perfect. This looks good. Now the next step is to sign the token using the private key that is corresponding to this public key. So to do that, we're going to click on sign, and then we're going to select our signing key. In this case, we only have one. Click OK. This looks good. Now if we go back to raw over here, this is our newly modified token. If we did everything correctly, when we submit this to the application should look at the JKU parameter in the header of the JWT, fetch the URL. From there, it should fetch the public key and use it to verify the signature of the token. Now, since the token was signed with a private key that corresponds to this public key, the verification should pass. So let's try to access the admin panel, hit send, and we get a 200 OK, which means that we were able to access the admin panel. Now the next step is just to delete the Carlos user so that we could complete the lab. So let's copy the URL for that, paste it in here, hit send, and here we go. We get congratulations, you solved the lab. All right, so we successfully completed the exercise. In the next lab, we'll look at another attack vector for JSON Web Tokens.